Welcome to the Deep Dive, your shortcut to truly understanding the world's most fascinating topics. Today we're diving headfirst into 3D media, unlocking the realm of imagination. This isn't just about, cool visuals. We're talking about the backbone of movie and TV production, video game development.
Architecture, product visualization.
Exactly. And medical imaging, VR, AR, it's everywhere. Our mission today is to really distill the key insights, maybe some surprising facts, and the true impact of this field straight from the source material.
Yeah, it's actually kind of captivating to see how 3D tech has fundamentally revolutionized how we create, visualize, experience our digital worlds. We're not just going to tell you what 3D media is. We want to pull back the curtain a bit on why it's rocking our world, give you that bigger picture.
Absolutely. And speaking of incredible stuff, some sources mention these like jaw-dropping 3D animations made with software like Blender, and they playfully suggest today's learning allows us to make all the animations in the video. Okay, maybe we'll be winning an Oscar this afternoon.
Probably not today.
But we are going to give you that crucial first taste, right? Focusing on basic techniques, so practical examples, using tools like Sketchup, which the sources also mention. Okay, let's unpack this then. When we talk about 3D modeling, what are we actually doing? Is it like digital sculpting or virtual blocks? What's the core idea?
That's a great place to start because, at its core, 3D modeling is the process of creating objects in three-dimensional space. Think of it like building a digital sculpture, piece by piece. You're working with these fundamental bits, points, lines, planes, in the software. And you use those to create shapes that actually have volume, not just flat images.
Okay.
And the cool thing is these shapes can be super simple, like basic forms, cubes, spheres, cones, or they can be incredibly complex custom designs. Think detailed cars, soaring buildings, or, complex character models for games or movies.
Right. So once we get what we're building with, how do we actually build it? Are there different, methods, different approaches?
Oh, definitely. There are some crucial common techniques. Direct modeling is maybe the most intuitive. It lets you just create and modify things right there on the screen, like molding digital clay directly.
Okay, hands-on.
Exactly. Then you've got parametric modeling. This is more like building with smart Legos, maybe. You define rules and constraints. So if you say a window needs to be halfway up a wall, changing the wall height automatically moves the window. It's really powerful for designs that need to adapt, like in engineering or product design. And finally, there's sculpting, which is much more free-form, more organic. It lets you shape the model by sort of adding and removing digital material, very much like real-world clay sculpting.
That distinction makes a lot of sense.
Yeah.
And this next bit really drives it home. Different 3D software can be better suited for specific approaches, right?
Precisely.
Like SketchUp, mentioned in the sources, it leans heavily on direct modeling. Makes it great for architecture, product design, where that immediate manipulation is key. But then you have something like ZBrush, which excels at sculpting. And that's why it's huge in movies and games for those really intricate characters and creatures. You can see some amazing examples in the source images, buildings, people, complex machinery, all modeled.
And stepping back a bit, the bigger picture here is, it's just crucially important to understand and master the software's tools and workflow. It's not just about knowing buttons, it's the interface, how you operate objects, organize your projects. Plus, for anyone serious about the art side, you really need to practice basic art and design principles. Shape, proportion, color, lighting, those fundamentals.
Right, they amplify the tech skills.
Absolutely, they work together.
Okay, so we've built our digital sculptures. How do we make them look real? How do we go from the model to the visual? That seems to be where rendering comes in. This process that turns the 3D models into, 2D images or animations.
Yeah, rendering. And what's really remarkable is how much it relies on simulating light. It's all about light. Take ray tracing, for instance. It's a technique that actually simulates how light rays travel in the real world. It captures details like reflection light bouncing off surfaces and refraction light bending as it passes through things like glass or water.
Wow.
It's an incredibly powerful simulation. It even gets into complex stuff like diffraction, which is maybe too much for today, but it's fascinating. And think about this. A decade ago, doing ray tracing in real time, that was science fiction.
Impossible.
Now, we're seeing it in video games we play every day. It completely blurs the line between pre-rendered movie effects and interactive stuff. That computational jump is huge.
So it's not just making a pretty picture, it's simulating the actual physics of light. And that informs everything else.
Exactly that. Which leads us to shadows. They're created by figuring out the position of the light source relative to the object. Shadows add vital depth, make things feel solid, and you get different kinds.
Like hard and soft shadows.
Precisely. Hard shadows have sharp edges, like from the sun on a clear day. Soft shadows are blurrier, more like from cloudy skies or indoor lights. Adds realism. And of course, reflection. An object's ability to bounce light back. This maps the surrounding environment onto the object's surface, makes it look grounded in its world. And again, distinctions. Specular reflection is that bright highlight, light bouncing directly back. Diffuse reflection is softer, light scattering evenly across the surface, creating a gentle glow.
So putting it all together, what does this mean for us looking at it? These techniques are what give that incredible detail, right? Make 3D models feel real when they become 2D.
Absolutely. They bridge that gap.
Our sources point to just how powerful modern rendering is. You can see it in those video examples like Eyepiece or the Pothead character trailer. The realism is just, yes, stunning.
It really is.
Okay, models built, rendered, but how do they fit into a believable scene? That seems to be about materials and lighting working together.
Critically important, and they are totally complementary.
So materials, first they define the surface, right? Color, texture, how shiny it is.
Exactly. Think of a wooden object. Its material includes the brown color, maybe a wood grain texture image applied to it, and a specific level of reflectiveness to simulate that natural wood shine.
Got it. And lighting. That's simulating the actual light sources.
Yep, simulating real-world lights. It affects the color and brightness of everything, and crucially, it creates those shadows we talked about. Like, a strong single-point light source will cast very clear shadows and create strong highlights, defining the object's form.
Okay, makes sense.
And the profound impact here is we can go deep, we can talk advanced concepts, textures, for instance. That's applying detailed images onto surfaces. Think like the scratches on metal or the weave of fabric, incredible detail. Reflections and refractions become key for materials like metal or glass, how light bounces off or passes through. And then there are light models. These are like the secret mathematical recipes artists use. They define exactly how light interacts with different surface types. Think velvet versus chrome, totally different sheen, right?
Oh, okay.
These models make that visual distinction real, gives artists hyper-specific control.
To make that concrete, let's use that example.
Yeah.
Creating a realistic wooden table model.
Good idea.
You'd start by choosing a brown color image, maybe, for the basic wood tone.
Yep.
Then apply a wood grain texture image for that surface detail.
The pattern.
Set the right reflection level for wood's subtle shine. Not too glossy, not too dull.
Crucial detail.
And then add maybe a point light, like an indoor lamp, to create those natural light and shadow variations across the table surface.
And suddenly it looks like it belongs in a room. It's about building that digital illusion, layer by layer.
Okay, so modeling builds it, rendering makes it visual, materials and lighting set the scene. But how do we make things move? Give them life, personality. That brings us to 3D animation production,
Where the magic happens.
One core technique mentioned is keyframe animation. How does that work?
It's fundamental. You basically set the model's position or rotation or state at specific points in time. Those points are your keyframes. The computer then does the heavy lifting. It calculates and creates all the smooth movement between those keyframes.
So like the character jumping example.
Exactly. You set a keyframe, character on the ground, next keyframe, character at the peak of the jump, final keyframe, character back on the ground.
And the computer figures out the arc, the timing.
Precisely. It interpolates the movement, makes animation much more manageable.
Okay. And what about path animation?
Path animation is another common one. It lets a model follow a predefined path you draw out. Really useful for complex movements, like a plane flying along a specific route, or planets orbiting.
So you define the track it follows.
Yep. You set the start, the end, maybe some points along the way, define the path shape, and the object sticks to it. Gives you lots of control over trajectory.
And, critically, once things are moving, how do we watch them? How do we present that motion effectively? That seems to be the job of camera techniques.
Absolutely pivotal. The camera is literally your window into the 3D scene. Just by adjusting its position, its angle, its focus, you completely control the audience's perspective, what they see, how they see it.
The sources mention different lens types,
Yeah.
like wide angle versus long focus.
Right. Wide-angle lenses give you that broad vista, great for establishing shots, big environments. Long-focus lenses compress distance, bring far objects closer. Perfect for tight close-ups, focusing on detail or emotion.
And you can move the camera, too, dynamically.
Oh, yeah. Zooming in to draw attention to a character or object, panning the camera to follow movement or explore a landscape, tilting, dollying, all the cinematic language applies. And this really highlights a key point in storytelling, doesn't it? These camera techniques aren't just cosmetic. They are essential for guiding the viewer's eye, enhancing visual impact, and, crucially, building tension or emotion in the story. It's visual communication.
Directing the audience's experience.
Exactly.
Okay, now, here's where it seems to get really interesting. We've got the basics down: modeling, rendering, animation. But how do you push beyond that? Achieve that next level of detail, that jaw-dropping realism?
This is where advanced 3D design knowledge really shines. Two key techniques mentioned are subdivision and physical dynamics.
Subdivision. What's that about?
Subdivision is a clever way to add detail to a model without making it overly complex to manage. Think of it like taking a basic shape and telling the software to intelligently add more points and polygons, smoothing it out, refining it.
So like the cube example, you apply subdivision.
And its sharp edges become rounded, it starts looking more like a sphere, but based on that original simple cube structure, adds detail efficiently.
Cool. And physical dynamics, that sounds like physics class.
It basically is. You're plugging real-world physics rules, gravity, friction, collisions into your 3D scene. This makes your digital objects behave much more like physical objects.
Like the ball rolling down a slope example.
Perfect example. With physics enabled, the ball naturally rolls faster downhill because of gravity. Add friction and it slows down, maybe stops, just like reality. Makes the digital world feel grounded and believable.
Right, makes it feel alive. And then there are even more advanced techniques for really complex stuff like fire, smoke, special effects.
Yes, moving into simulation territory. Particle systems are huge here.
Particle systems, what are they?
They're incredibly powerful tools for simulating all sorts of natural phenomena, fire, smoke, but also hair, snow, rain, sparks, lots of things made of many small parts.
How do they work?
Well, they're made of lots of tiny individual particles. Each particle has its own properties, location, speed, maybe color, how long it lasts. And they behave according to rules you set. So for fire, you'd have particles moving upward, fading out, changing color from yellow to red, mimicking how real fire behaves.
Wow. The sources mentioned the Unity Particle Pack video shows this off.
Yeah, that's a great visual example of the kind of dynamic effects you can create. Really brings environments to life.
And beyond particles, mimicking other real-world forces.
That's where simulation plugins often come in. These are add-ons that expand what the software can do, specifically for mimicking complex physics. Think cloth simulation, making fabric hang and move naturally. Hair simulation, making hair flow and react to movement. Liquid simulation for water, smoke, explosions. Even solid body physics for things breaking or collapsing realistically.
So they use actual physics laws?
Often, yes. They rely on things like Newton's laws and properties of materials like mass, elasticity, friction, all calculated by the computer. The Blender 3D physics simulation showreel mentioned is a fantastic showcase of just how convincing these simulations can be. It's mind-blowing stuff sometimes.
Incredible. And finally, wrapping up the advanced techniques, scripts and plugins. These sound more like workflow tools.
They are, but they're incredibly powerful workflow tools. Scripts are basically little programs you write or use to automate repetitive tasks. Imagine needing a forest scene with thousands of trees, instead of placing each one by hand.
You run a script.
Exactly. Run a script and boom, instant forest. Saves enormous amounts of time, makes complex scenes feasible.
And plugins. We mentioned simulation plugins, but are there others?
Oh yeah. Plugins provide all sorts of special functions. Could be advanced rendering features, specific modeling tools, those particle systems we talked about, or effect generators. Like you could use a plugin to quickly add realistic rain to your scene, complete with splashes and wet surfaces. They extend the capabilities of the core software significantly.
Makes sense. Efficiency and expanded power.
That's the idea. You know, we've covered a really wide range of fundamental 3D production knowledge today, from the absolute basics of making a shape right through to these complex simulations. But it's really important to stress mastering this stuff, especially to a professional level for movies or games. That typically takes years, often decades. It really underscores the incredible skill and, frankly, the hard work involved in creating those visuals we often take for granted.
Absolutely. So thinking about that skill and time investment, what does the future hold? Especially with things like AI. Our sources touch on AIGC, artificial intelligence generated content in the 3D space. What's the thinking there?
Well, the sources know it's still developing, right? It's not fully mature yet.
Right.
But it's making significant breakthroughs. The potential is there for AI to generate 3D assets, maybe even animations, potentially lowering the barrier to entry. It points towards a future with potentially limitless, immersive, dynamic experiences, maybe generated on the fly. It could really transform how we visualize and interact with digital content.
As the source says, let's look forward to future developments. It's definitely one to watch. And practically speaking, the source gives a clear next step. Next, let's start practicing with SketchUp.
Right.
Time to get hands-on.
Which actually brings up a really interesting question to ponder. As this AIGC stuff keeps getting better and faster in 3D, how is that going to change things? Will it make high-end 3D creation accessible to almost anyone? And what new kinds of creativity might emerge from artists who don't have that traditional decade-long training background, but now have these powerful AI tools? What new art forms might we see?
That is a provocative thought. What does democratized 3D creation look like? A great question to leave our listeners with. Thank you for joining us on this deep dive into the incredible world of 3D media. We encourage you to keep exploring these possibilities.